In this lesson, we will be doing a review of Pythagorean Theorem. So the Pythagorean Theorem states that in a right angle triangle, the long side of the triangle, called the hypotenuse, is equal to the sum of the squares of the two other sides. We call these legs, so side A and side B. So a squared plus b squared will be equal to c squared. You can use this theorem to determine the length of an unknown side in a right triangle. So for example, you can use Pythagorean theorem to determine the length of the hypotenuse in this triangle. So if a squared plus b squared equals c squared, and in this triangle, I've got two legs, A and B, and it doesn't matter which one is A and B, and the hypotenuse, C, it means that 5 squared plus 12 squared will be equal to x squared, or c squared. If we evaluate this, we get 25 plus 144 is equal to x squared, and 25 plus 144 is 169, so I keep writing c, and I mean to write x. And then if I want to solve for x, I would take the square root of 169 to be left with just x, because I would be square rooting both sides. And the square root of 169 is 13. So the hypotenuse in this triangle is 13, and it's 13 inches in this scenario. Similarly, in example 1, I can determine the measure of this unknown side in the exact same way. So again, I have side A and side B. It doesn't matter which one is which, as long as you recognize that this unknown is the longest side. It's the side across from the right angle, which is the hypotenuse. So in this case, 4 squared plus 6 squared will be equal to c squared. Now 4 squared is 16, and 6 squared is 36. When I add those up, I get 52 is equal to c squared. Now, in the previous example, when I took the square root, this answer was a nice whole number because 169 is a perfect square. In this case, the square root of 52 is equal to approximately 7.21, and these are in centimeters. So that is the length of the hypotenuse. We can also use this theorem to solve for the length of either of the legs. And to do this, all that you're going to do is rearrange the formula so that you can solve for either A or B. The steps are the same. The first thing that you want to do is label the sides of your triangle with A, B, and C. So in this triangle, we've got side A, side B, and side C. Remember, side A and side B can be interchanged as long as side C is always the hypotenuse, which again is right across diagonally from the right angle. So in this case, I'm looking to solve for side A. So I'm going to use this version of the formula that's been rearranged. So a squared is what I'm solving for, which is why I chose this one, and that is equal to the hypotenuse squared minus b squared. So if I plug in my values that I know, 8 squared minus 5 squared. So a squared is equal to 8 squared is 64, and 5 squared is 25. When you do that subtraction, you're left with a squared is equal to 39, And then you're going to take the square root of both sides. So a is equal to the square root of 39. And when you put that in a calculator, you'll notice in the question, it asked you to round to 1 decimal place. So it's 6.2 centimeters. Very similarly, in example 3, we have a fire truck's extension ladder that's leaning against a building. So its top just touches the gutters at the edge of the roof. If we know the ladder here is 41 feet long and it's 9 feet away from the wall at the bottom, how tall is the building? So this side here, the height of the building, is our unknown. So in this case, the sides were already labeled A and C, so this is side B. If I'm looking for side B, I know that B squared will be equal to the hypotenuse squared minus A squared. That formula is also right above on this page. If I then plug in those values, I get that B squared is equal to 41 squared minus 9 squared. So B squared is equal to 1,681 minus 81. So B squared is equal to 1,600. If I then take the square root, B will be equal to the square root of 1,600, which is 40. And in this case, the units are feet. So 40 feet. The next page, one more question. A park is 36 meters by 27 meters, and it's rectangular. A construction team is going to build a path diagonally across the park. How long will the path be? So in this case, we've got our drawing already sketched for you. The park is 27 by 36. You'll notice that this creates two triangles. Now in a rectangle, if this side is 27, then this side is also 27. And if the width is 36, then at the top will also be 36. So if I use this triangle here, and because it's a rectangle, I know that it's going to have a 90-degree angle. I've got a triangle where I know both sides, and I'm looking for the hypotenuse. I've got a leg and another leg and the hypotenuse. So I can use Pythagorean Theorem. A squared plus B squared equals C squared. When I substitute in 27 squared plus 36 squared equals C squared. And then that's equal to 729 plus 1,296. I'm going to add those together, which equals 2,025. And then I'm going to take the square root. Square root of 2,025 will be equal to C. And when you put that in your calculator, it gives you a value of 45, and we're in meters. So the path, the diagonal there, will be 45 meters long.